Okay, to simplify a rational expression, a fraction, you need to do division. The problem is, in order to do division, your expression must be connected by multiplication. So if you look here, 16 minus b squared and 2b minus 8 are not terms connected by multiplication. So you cannot start the division process. These terms are stuck together. These terms are stuck together. However, we can fix that. We have learned all about factoring, and we know factoring will rewrite a polynomial in multiplication form. Now, we got to go through our rules of factoring. We had 5 of them, but we're going to be working with the big 3. GCF, difference of perfect squares, and trinomial. So if I have 16 minus b squared, what rule is that? That's right, that's a difference of perfect squares, and I'm going to write it here. If I have 2b minus 8, what rule of factoring is that? That's right, they have something in common. We're going to do GCF. So what we're about to do is factor the numerator, factor the denominator. Once we get it connected by multiplication, then we could do the division. So if this is a difference of perfect squares, we know we put 2 parentheses. 16 is 4 times 4. B squared is b times b. They should be conjugates. One gets a plus, one gets a minus. In the denominator, our common factor is 2. We're going to divide both terms by 2. So we're going to pull out a 2, and that's going to leave us with b minus 4. So the first thing we do is rewrite our expression as multiplication. That's what factoring is all about. Now that it's connected by multiplication, we can do division. We are looking for 2 things. We are either looking for terms that are exactly alike, because we divide the same amount, our answer is 1, or we're looking for additive inverses, opposites. Our answer would be -1. If we have conjugates, then we can't do anything with that. So the first thing I want you to look at is 4 plus b and b minus 4. They're obviously not the same. This 4 is negative, this 4 is positive. So if this 4 is positive and that 4 is negative, they're opposites. But to be additive inverses, then every term in the parentheses has to be opposite. That b is positive and that b is positive. They're not opposites. So these are not the same, these are not opposites, these are conjugates. If we wrote this in the correct descending order, this would be b plus 4. And b plus 4 and b minus 4 are conjugates. So we can't do anything with that expression. What do you know about 4 minus b and b minus 4? Well, they're not the same. That 4 is positive, that 4 is negative. They're opposites. That b is negative, that b is positive. They're also opposites. So if every term in your expression is opposites, we call these binomials additive inverses. And when we divide additive inverses, our answer is always -1. Now, does it matter where you put the -1? Sure. We never want a negative in the denominator, so we're going to put the -1 in the numerator. And that is connected by multiplication. So now in your numerator, you have 4 plus b times -1 over 2. Most professors will not accept that because, guys, in your numerator, you're connected by multiplication. So you have to multiply that through. So 4 times -1 is -4. B times -1 is -b. And we're dividing by 2. Is that our final expression? Yes, it is. Now, most of you are going to make the careless mistake in dividing the 2 into the 4. Again, is every term up here connected by multiplication? No, this is a minus, which means there's no more division. Put that in parentheses so you know it's connected together. That is your final fraction. Let's try one more. Here's an ugly looking one in algebra. 3y squared minus 15y plus 18 divided by y squared minus y minus 6. The biggest mistake you guys make is you see the division bar and you divide the y squared with the y squared and the y with the y and 18 and 6. You can't do that. This is not connected by multiplication. It has to stay together. This is not connected by multiplication. It has to stay together. So to rewrite it, we're going to use our factoring skills. So let's go to the numerator. Even though there's 3 pieces here, they have a GCF. What is the GCF? It's a 3. So I'm going to take out a 3 and write what's left. Y squared minus 5y plus 6. Now are we done? No. Inside we still have 3 terms. Now we have a trinomial rule. It is easy. It has a coefficient of 1. So we're going to factor that some more. So we know we're going to leave the 3, we're going to write our 2 parentheses, and we're going to do backwards FOIL. Y squared is y times y. 6 can be 1 times 6 and 2 and 3. How do I know which one? I want to add to 5. Well, that's got to be 2 and 3. If I want to add to a negative 5, they both have to be negative. So your numerator completely factored is 3y minus 2 times y minus 3. Now we're going to factor the denominator. It also has 3 terms. There is no GCF, so we're going to go right to our rule of putting our 2 parentheses and doing backwards FOIL. Y squared is y times y. I want to multiply to 6. Well, again, my options are 1 and 6, 2 and 3. I want to subtract now to make this coefficient 1. Well, it's got to be 2 and 3. Subtract means these signs are going to be different. Subtracting to a negative, the negative goes to the larger, so the 3 becomes negative, the 2 comes positive. So now in this fraction, I have in the denominator a y plus 2 over a y minus 3. We're done factoring. Now we're ready to divide, cancel. Y minus 2 and y plus 2 are conjugates. I can't do anything with that. But a y minus 3 and a y minus 3 are exact same binomial. When you divide the same binomial, it cancels out and makes a 1. So what we're left with is in the numerator 3, y minus 2, and in the denominator y plus 2. That's one way to write the reduced fraction. Another way would take the 3 and distribute it. So this is really 3y minus 6 over y plus 2. And that's another way to write the simplified fraction. So in the end, reducing fractions so much fun. Factor, cancel, then you're done.